So we are now in chapter 16, and we are going to be doing okay, and so I'm going to just sort of start off with the big equation. The big equation is F equals K Q1 Q2 over R squared. So this is the force between two charges. Now that's going to look very, very similar to an equation we encountered earlier. That, which we did before, was the force between two masses, and so it was the gravitational. So let's look at the two side by side. We have F is force, and we're going to measure that in newtons, which are kilogram meters per second squared. And then we're going to have over here the same thing. Now again, R is going to be distance between two charges, and that's measured in meters. And R over here is going to be the distance between two masses, and that's measured in meters. And now here's where we get the difference. We say Q is an electric charge, and that's measured in coulombs, which we're just going to say is capital C. And over here, M is mass, measured in kilograms. And then finally we have our constants. We have K is Coulomb's constant, and it has a value of 9 times 10 to the 9th newtons meter squared per coulomb squared. And over here, G is the universal gravitational constant, and its units are, and it is 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. Okay, so there's our two equations. And so let's just figure out if we have an atom And we're going to say that we have an electron. And that electron is going to have a mass of 9.11 times 10 to the negative 31 kilograms, and it's going to have a charge of negative 1.6 times 10 to the negative 19th coulombs. And we're going to have a proton, and the proton's going to have a mass of 1.67 times 10 to the negative 27th kilograms, and it's going to have a charge of positive, same thing exactly, 1.6 times 10 to the negative 19th coulombs. So the charges on an electron and a proton are exactly the same, just opposite signs. And then the proton has a mass that is much larger than the electron's mass. So one of the things that they ask is, why do electrons carry electric current? So when we're talking about electricity moving, we're basically talking about the movement of electrons. And the reason why electrons are the ones that move are because they are much lighter. And so because of F equals ma, if you look at the force between an electron and a proton, well, this one is 4 orders of magnitude more massive than the electron, and so it's going to have 4 orders of magnitude less acceleration. So basically the same force, this one's going to have, roughly speaking, somewhere around 5,000 times the acceleration. Okay, so I don't think I'm going to be able to squeeze in everything I want to do in this video, but what I'm going to do is, in the next video, I'm going to say that the distance between these two is approximately 1 times 10 to the negative 10th meters is going to be our R. And so now we're going to find a and so then what we're going to do is we're going to basically find the electric force between an electron and a proton roughly speaking, in a hydrogen atom, and then the gravitational force between them as well. So rather than squeezing that into the next minute, I'm going to stop and do another video.